Scientists discovered super Earth with an atmosphere, a major milestone in the search for alien life. A groundbreaking discovery brings scientists closer to finding life beyond Earth. The search for extraterrestrial life has taken an exciting step forward after astronomers discovered a rocky super Earth with a confirmed atmosphere located just 48 light years away from Earth. Now let's go beyond the surface and reveal every layer of this story in our AI video explainer.
All right, let's jump right in. Welcome to today's Explainer, where we're unpacking a massive astronomical milestone. Seriously, this discovery brings us one giant step closer to answering the ultimate cosmic mystery. We are looking at a brand new breakthrough in exoplanet research, and I am absolutely pumped to show you how scientists pulled this off, why it's such a game changer, and what it means for our future in space. Are we alone in the universe? It's a question that has captivated humanity for generations, right? Every time we look up at the night sky, we kind of can't help but wonder if someone or something is looking back at us across the dark. Well, today, thanks to some brilliant scientific detective work, we actually have a thrilling new clue to help us answer that with hard data. Section 1, the ultimate cosmic question. So, to really grasp why this new discovery is so monumental, we need to zoom out first and look at the sheer, vast scale of our search so far. Over the past few decades, astronomers have discovered more than 5,000 exoplanets out there. 5,000! That's an incredible catalog of distant worlds. But here's the catch. Finding a planet that could actually support life is literally like finding a needle in a cosmic haystack. Most of these exoplanets are totally uninhabitable, raging gas giants or scorching hot worlds. We're looking for something very specific, something quiet and stable. Section 2. Meet Super Earth LHS 140b. I want to introduce you to our prime suspect in this cosmic stakeout, a fascinating, mysterious world located about 48 light-years away from us. Let's look at the profile for this distant world. LHS 1140b is classified as a super Earth. It's roughly 1.7 times larger than our home planet and weighs in at about 5.6 times as massive. But crucially, and this is a big one, it's rocky. It has a solid surface you could theoretically stand on, making it a far better candidate for life than a massive gas giant like Jupiter. Plus, it orbits a cool red dwarf star. Now, size and a solid surface aren't everything. What makes this planet truly special is its orbit. It sits squarely in the Goldilocks zone of its host star. Not too hot, not too cold. It's the exact perfect region where temperatures might just allow liquid water to pool on the surface. And as we all know, liquid water is the absolute essential prerequisite for life to begin. But being in a good neighborhood isn't enough on its own. As lead researcher Dr. Colin Cherubim explains perfectly right here, you absolutely need an atmosphere. You have to have it to protect the surface from harmful radiation and to support a stable climate. Without it, you just have a sun-baked rock, no matter how good the orbit is. Which brings us to Section 3, the atmosphere problem. The real test is figuring out if this rocky world actually has an atmosphere. And let me tell you, checking for air on a rock 48 light-years away, yeah, it's way harder than it sounds. Here is the core of the problem. Atmospheric gases are incredibly thin. Now compare that microscopic layer of gas to the blinding, overwhelming brightness of the giant star the planet is orbiting. Even with incredibly powerful tools like the James Webb Space Telescope, spotting these gases is quite literally like trying to see a firefly next to a military-grade searchlight. So how do we solve this? Scientists use the transit method. Basically, they wait for the planet to cross directly in front of its host star. When it does, they measure the tiny, almost imperceptible dip in the star's brightness. As that starlight filters through the very edges of the planet, they look for specific wavelengths of light that have been absorbed. Those missing wavelengths are basically chemical fingerprints left behind by the gases. And this is exactly why LHS 1140b is such an amazing target. It orbits a red dwarf. These stars are much smaller and cooler than our sun. Because the star is smaller, the planet naturally blocks a much larger percentage of the overall starlight. This geometric quirk acts like an amplifier, giving our telescopes a massive advantage in reading those elusive atmospheric signals. Section 4, a lucky astronomical breakthrough. Even with that red dwarf advantage, researchers needed a fresh approach. And this is where the detective work gets incredibly clever. Instead of struggling to find heavy, low-lying gases deep down like water or carbon dioxide, the team made a huge strategic pivot. They went looking for helium in the planet's highly extended upper atmosphere. Why? Because helium expands far out into space and absorbs very specific, super easy to spot wavelengths of light. If you find helium, you've got incredibly strong evidence that the planet has held on to its atmosphere. And then came the lucky break. Scientists were using the Wiener-Red spectrograph at the Magellan Observatory down in Chile when a very rare event occurred: a double transit. Two planets in this system crossed the star on the exact same night. The neighboring planet showed absolutely no atmospheric signals whatsoever, just a dead rock. But LHS 140b, it revealed a glowing cloud of escaping helium. Absolute, undeniable confirmation. You can literally feel the raw excitement in this quote from study co-author Dr. Shreyas Visapragada. He calls it an absolute thrill. Imagine crunching this data and realizing you are the first human beings in history to directly detect an atmosphere on a rocky planet inside a habitable zone. That's a true textbook scientific eureka moment. Section 5. An atmosphere built to last. Okay, so finding the atmosphere was a massive thrill, for sure. But what they subsequently discovered about its resilience is what transforms this into a true scientific marvel. Let that number sink in for a second. 3 billion. Based on their observations, scientists estimate that LHS 1140b has successfully held on to this atmosphere for more than 3 billion years. We aren't just talking about a fleeting puff of gas here. This is an ancient, enduring feature of this alien world. And that age is incredibly important. You see, many rocky planets just get their atmospheres completely stripped away by intense stellar winds and harsh radiation. The fact that LHS 1140b has survived this constant bombardment for billions of years means its climate is stable. It's been around long enough for complex chemical processes to potentially develop over eons. Section 6. What comes next? We've got the rock, we've got the orbit, we've got the atmosphere. This discovery is a monumental milestone, but really, it's just the opening chapter of an even grander investigation. Just look at this timeline from study co-author Robin Wordsworth. 20 years ago, we were literally just wondering if these planets even existed. Then we learned they're common. Then we found them in the habitable zone. And present day, we are confirming their atmospheres. Our understanding of the universe is evolving at a breakneck pace. So, the immediate next step is deploying our most advanced tools to scan this newly confirmed atmosphere for specific biosignatures. We're going hunting for things like water vapor, carbon dioxide, methane, oxygen, and ozone. Finding the right combination of these gases could be the strongest evidence we've ever had of biological activity. Now, reality check for a second. Finding an atmosphere does not automatically mean we found life. Actually, we are still a long way from confirming aliens. But what this discovery absolutely does is skyrocket LHS 1140b to the very top of our most promising candidate list. It's definitively a prime target for future study. Which brings us to the ultimate takeaway. As our space telescopes grow ever more powerful, we are left looking at this distant rocky world and wondering, will LHS 1140b be the planet that finally reveals that Earth isn't unique? Could this be the exact place that proves we aren't alone in the vast, quiet cosmos? Thank you so much for joining me on this explainer today. I absolutely cannot wait to see what they discover next.
Okay, one question for you. Scientists have now confirmed that the super Earth LHS 1140b has an atmosphere and lies within the star's habitable zone. Do you believe this discovery increases the chances that the intelligent alien civilizations exist somewhere in our galaxy? Or do you think life beyond Earth is still extremely unlikely? Explain your thoughts. Thanks.